Okay, so question 1, it asks us to mark the angle of elevation, and we're going to label it theta and then find its size. So question 1a, an angle of elevation, remember it has to be between a horizontal line and another line, the line of sight. So we've got two horizontal lines. We've got this one horizontal line here, and we've got this horizontal line down the bottom here. Now, if it's an angle of elevation, then the line of sight has to be above the horizontal. Okay, so when you look out at the horizontal, you then have to angle your sight upwards from that line. So we can't use this horizontal up here, because if we were to angle our line of sight upwards, we're going to end up here somewhere. We have to end up above the diagram, and there's nothing up here. So we can't create an angle up here. So we're going to need to use this bottom horizontal line. Now from this bottom horizontal line, can we create a line of sight that comes up? Yes, we can. We can use this line here, looking up from the horizontal. So this is our horizontal. This is our line of sight that goes up. So the angle that we created is just going to be the angle in between these two lines here. So this is our angle of elevation. It starts at the horizontal and then it moves up from the horizontal until it's looking up here towards this corner up here. Now we've found the angle of elevation, it's here. So this is theta, we can label that theta. Now what size is theta going to be? Well, we know that the angle sum of a triangle is 180 degrees. So we know that if we add up all of these angles inside the triangle, 70 degrees plus 90 degrees plus theta, we know that we have to end up with 180 as our sum. So if we want to work out what theta is, well, we know that 70 plus 90 is 160. So what's left over to make 180? Well, 180 minus 160 is just 20. So this must be 20 here, because then we've got 20 plus 70 plus 90, and that adds up to 180. So that makes sense for a triangle. So theta's here, and it has to be 20 degrees. Over here, same kind of thing. The angle of elevation, again, it has to be measured from the horizontal. We can't use this horizontal up here because then our angle is going to be up here somewhere because it's elevated. It's the angle of elevation, which means we have to go up. If it was an angle of depression, we could use it because then we could go down and we could say that this here, this is the angle of depression. But because it's an angle of elevation, we need to go up from the horizontal, and there's nothing up here, so we can't use this horizontal line. We have to use this horizontal line down here. So this one, can we create another line that goes up? Can we create an angle that goes up from this horizontal line? Yes, we can. We can create this angle here with the line of sight that's above the horizontal line. So that creates this angle here. And so we can label that theta. And what is the size of theta? Well, I can see that this 30 degrees here is actually an alternate angle to this angle theta, because we've got two parallel lines. We've got this horizontal line and this horizontal line here. And when we have that Z shape between two parallel lines, we've got that transversal cutting across the two lines, we know that the angles inside that Z shape are going to be equal because they're alternate angles. That's just a definition that we have to remember. So this angle here is going to be equal to this angle here. So that means theta is 30 degrees. This one here, again, it's the same sort of thing with the angle of elevation. We have to measure from a horizontal. We've got a horizontal here that we can measure upwards from. So if we were to create an angle that moves upwards from the horizontal, it has to be this angle here. This is our line of sight, and this is our horizontal, and we can create an angle of elevation in there. We can't create one from this horizontal line because we have to move up from there, and there's nothing up here. We can't create an angle up here because there are no angles, there's no lines up here. So we know we're not using this line, we're using this horizontal. And the only angle that we can create here is the right angle, which we already know, or this angle of elevation here, which comes up from the horizontal. And again, we can see that this is parallel to this line. These are both horizontal lines, so they're parallel lines. And we've got a Z shape with this transversal that cuts across the two parallel lines, which means we've got two alternate angles. So this angle here has to be equal to this angle theta, because alternate angles in two parallel lines are always equal. So again, theta is just 54 in this case. And question 2 is the same sort of thing, except we're looking at angles of depression this time. So we find our horizontal, and then we have to create an angle below the horizontal. So we're not going to be able to use this bottom horizontal this time, because if we need to create an angle below the horizontal, we're going to be down here below our diagram. There's no angles here, there's no lines, so we're not going to be using this horizontal. We need to use this horizontal here. And from here, we need to create an angle that's between our horizontal and our line of sight. So it's not going to be this 41 degrees, that's between the line of sight and the vertical. This is a vertical line here. So we need to be careful with that. It's between the horizontal and the line of sight. So it's this angle created in here by these two lines. So this angle here is our angle of depression in this diagram. That's the only angle of depression we can find in this diagram. So we label that theta. And we need to find its size. But I can see that this angle here is 41 degrees. And I know that if I add this angle to this angle, well, this whole angle here, this is a corner of our rectangle. So this is a right angle. So I know that this angle here has to add up to 90 degrees. And part of it, this part here is 41 degrees. So the other part, well, it has to make up 90 degrees. So what's 90 minus 41? What's the difference between 41 and 90? 49. So this side has to be 49 degrees, this angle here. And we know that because we know this angle, 41, plus our angle theta here, our angle of depression, when we add those two angles together, it should add up to 90 because this is a right angle here. Okay, I'll leave B and C for you to try, but remember the angle of depression is the angle between the horizontal and a line of sight that's below the horizontal, okay, not above the horizontal. So you're not going to be able to use this top line. You are going to be able to use the top line. You're not going to be able to use this bottom line because you can't really go below this bottom line. There's no diagram here. There's no angle. There's no lines. So you have to determine which horizontal you're using and where you can actually create an angle of depression that comes down from the horizontal.